So yesterday we are talking about sample versus population, and we discussed that sample is always about a partition. I mean, a random set of data from population. We may not be able to compute all the population data or collect all the population data. All we can do is we can collect only some subset of the population. And what is a population? Population is all the possible outcomes for a particular variable. So let's say I'm talking about average GPA of students taking math major. It means that I'm going to take all the students of all the I mean all the students who are taking math major in all the countries across the world. So in these circumstances, most of the times you will not have data at hand, or at least all the data at hand. All you are supposed to do is take a subset of the population, which is a sample, such that it is a representative of the population. As long as it is a representative of a population, we are good. So any questions on sample versus population? So unless we understand what is a sample, what is a population, we cannot we cannot really understand the rest of the subject.
Sandeep, I have a question here.
Yeah.
Regarding the sample, we are taking subset. Since we can't take all the values of the population, so we will take some of the elements and we can do. But how can we assure that that the sample which we took is not biased or anything?
Yes. So if you have to ensure that it is not biased, what is the only option? So for example, in this case, average GPA of students. So what is the best way to take all the, so that the sample is not biased? When you say sample is biased, what does it mean?
All belongs to same type or maximum or very less
Yeah,
deviation.
I'll give you one simple example which happened almost recently. US presidential election. Sorry. So in US, maybe last year we had a presidential election, right? In the election, many statisticians tried to evaluate who will win. They try to model the things, whatever they have at hand, and they try to model. Now, for modeling this, what they did is they collected data, obviously, right? So they collected data from. So first thing they did is they collected data from social media. Okay. Similarly, they collected data from surveys. They did their own surveys. They asked people to write down who they wanted to vote, and likewise they collected in many cities. Okay, this they did in from many cities. Now, can you tell what is the bias here? It's a generic topic, right? Presidential
Yes.
election. So that's why I took this example. So can you tell where the bias could be? So the reason I am asking about the bias here is all the statisticians said that Hillary Clinton will win, but still, to the surprise of many, Trump won.
Okay.
And that happened because obviously there is some bias in the data, right? That's why your prediction went wrong. So
Yes.
all these statisticians started working back. Okay, I predicted that Trump will win. He didn't. Sorry, Hillary will win, but Trump won. It means that I did something wrong. So they started backtracking on their process, and they found that there is a data bias. But before I tell what is a bias, can you try to identify where the bias came in? It's an interesting subject actually, understanding
Hmm.
the bias.
Actually, maybe when they are doing survey,
Hmm.
second point,
Hmm.
maybe they took the survey from the cities where majority of the people voted interested on Hillary Clinton.
Exactly. But when you collect the data, there is no statistical procedure to say that this is a bias. It's up to your intelligence. Did you get what I'm saying?
Yes,
So, in this process, when collecting the data, it's a manual process. There is no mathematics behind the scenes. It's all your human intelligence. You have to intelligently collect the sample properly. Obviously, you cannot collect all the population. If you're asking all the persons in the US, probably some of them may not be even voting for you in the survey. Anyway, collecting the population is impossible in this case, right?
yes,
All you can do is collect the sample. Now in the sample, collecting from social media is also educated, it's from educated people. This has urban population. So all you did is only two subsets of the population you did. What happened is these two, one is the social media and the second is the survey from cities. Both of them did not represent the population at all. As long as it is not represent, your sample is not representing your population, there will be some bias in the system, and the bias will it will try to pull your outcome from one place to another, like from Trump to Hillary. It The outcome got pulled, right?
yes,
So that's what happens when you collect a biased data. But how to identify that? No one can tell. These are what I'm talking about. These are the finest statisticians in the world, not even in US, but still they got wrong. So there is no one in the world who can tell this, but use your normal intelligence. So you can easily say that these two are not sufficient, right? Why they did go with these two? Because it is easy to collect. It is easy to collect from social media. It is easy to do a survey in cities, and it's very hard to do in suburban or uh, you know uh, country population, right?
yes,
So because it is not easy, they did not do it, but it doesn't mean that it's not valuable. They know that it is valuable, but because it is it doesn't mean that only I know about this problem. Even they know about this problem, but collecting from a survey in country population or suburban population is challenging, but that doesn't mean that you should not do it. Okay, are you
okay,
clear on this? Why I mean, how to identify the bias? Identification of bias is a simple common sense. Everyone knows that you cannot take a survey only in cities and then say the election results are like this. Only thing is how difficult it is to calculate in villages and suburban. Are you clear? Any questions on this?
no. Oh, fine, Sandeep, clear.
Okay. Okay. So based on this, there is a difference in population and sample, right? So always try to collect all categories of the population. Do not limit yourself to village population or urban population, or even in this case, do not limit yourself for only US students, because this requires for all the countries. So there are some implicit conditions that you'll know by just by looking at the problem at hand, but some things you cannot control at all. I mean, for example, in this average GPA of students taking math major, I'm not talking about which year. Is it a sophomore year, or is it a first year, second year of math major, or third year of math major? Because over the period of time, maybe some of the persons who got a GPA of, let's say, 2.5, let's say, might be improving to 3.2 in the second year. So some of these conditions are not implicit in the problem at hand, but whatever is implicit for you, try to collect all kinds of data for that, all kinds of samples for that. Try to divide your problem at hand into different categories. For each category, you try to acquire the data. Is that clear, Subbu, Abid, and Vidya?
Yeah, it's something.
Yes, Sandeep.
So in a way, what I'm saying is statistics cannot help in this case for collecting the data, because statistics is always about after you collect the data. It's not saying about before you collect the data. So that's how it is. So based on these sample and population, there are two different statistics that you can apply for your problem at hand, which I already mentioned yesterday, but let me give more details about it. So one is descriptive statistics, another is inferential, and both takes only sample data. So both descriptive statistics, inferential statistics, both the descriptive statistics and inferential statistics, the input is sample. You take the sample data and then do descriptive statistics or inferential statistics, but the outcome, what you get, so in descriptive statistics, outcome talks about sample, but in inferential statistics, here the outcome talks about population. And this is very important, because you always, whatever you collect is sample, but you can still talk about population. And this is the most important thing in inferential statistics. And let me give some examples about descriptive statistics, or before that, whatever statistic you calculate, whatever we calculate is called statistics here. Okay, the outcome calculates, or let me say, we calculate statistic. Whatever we calculate here in descriptive statistic, it is called statistic. And the examples for this is average, standard deviation. These are the statistics. Each one is statistic. Okay, average is a statistic, Standard deviation is statistic. And average in descriptive statistics, it's represented by X bar. And standard deviation in descriptive statistics, we call it as S. And in inferential statistics, whatever we talk about, it is called population, right? I mean, it is about population, right? So anyway, we cannot get the population exact value of the population. What we can do is we can estimate a parameter. Whatever we calculate, we estimate in the inferential statistics, it is called a parameter. It's not called statistic. And here the examples are mean, which is denoted by mu, and there is also standard deviation. In this case, it is denoted by sigma. So what I mean here is, let me give you an example. Let's say I have a data, population data like this. 1574. Only 4 elements in the population. But obviously, for the reasons that I specified earlier, I cannot collect this kind of a data because it is a population. Always I can go for sample. So let's say the sample is 1 and 7, or 1, 7 and 4, let's say. 3 elements, let's take. So the population data, the population, the sample statistic, which is X bar, is calculated as by 3. And the population mu is actually this one. How much it is? One plus 5 plus
4.2.
7 plus 4. 4.2 it is?
Hmm.
4.25. 4.25. Okay. And this one is 12 by 3, which is 4. Now, is X bar same as mu? X bar is not same as mu, right?
Yes, Sandeep.
X bar and mu are different. And is X bar, is there only one X bar? This is an important question. Is there only one X bar? Whatever I took is a sample 1. I can take another sample 2 from the same population. Let's say this is collected by Vijaya, for example. And let's say I'm taking another sample 1, 5 and 7. And this is collected by Sandeep. Okay, everyone can collect a different sample, right? Now the X bar will be 1 plus 5 plus 7 by 3, which is how much?
4.33.
13 by 4, right?
Yes.
Sorry, is that correct? 13 by 3. 4.33. Now, for every sample, this X bar will keep on changing. But is the mu changing? The population is always this one, right? Is the mu changing?
No, Sandeep.
Mu never changes. The population parameters never changes. Okay. So that is the 5th point. It is a variable. What is a variable? The statistic you compute, or let me call it as statistic is variable. The statistic is a variable. And here it is a constant. Right? So any questions on this constant or variable business? So, you keep on collecting different samples. Each sample will have a different X bar, which is my statistic, right? Statistic is nothing but whatever you compute on your sample. Now, the samples differ. Everyone might collect a different sample. So, even in the presidential election, everyone is collecting a different sample. Each statistician will collect from, let's say, I collect from Facebook. Some other person might have collected from Twitter, let's say. So everyone collects a different sample and different subset of the sample. And because of that, this statistic, the X bar, which is my average, is going to change for every sample. But if you take the population mu, which is a parameter, it never changes. It is a constant. So Subbu, Vidya, everyone, Abid,
Yes,
is
Sandeep.
everyone clear on this? Vidya, are you clear on this? And Subbu?
Yeah, yeah. So basically, there can be any n number of samples, but
Yes,
for population is only like one data set, basically.
exactly. Population is always never changing. And because of that, population parameters never changes. It means that it is a constant. And the other part, which is the statistic, is always changing because the underlying sample is changing. Subbu, are you clear on this?
Yes, Sandeep.
Yeah, be very clear on this part, the variable and constant part, because I'm going to use it. It's not something that it is hanging in the, hanging like that. Tomorrow I'm going to use it.
Okay.
Okay then. Now you know that what is the descriptive statistics, what is about inferential statistics, but I have not given exact examples on inferential statistics. We are going to see when we really pitch into the inferential statistics. Until then, you will not get real understanding about inferential statistics, because I am saying I'm estimating a population, estimating a parameter. But what does it mean by estimating? I did not say, right? So this part you may not be clear, but it's okay. That is understandable and agreeable for now. Now, let's go into descriptive statistics, or let me open a new page for that. Statistics. Now, I already mentioned all the data we collect is always a sample. It's not a population data. And for descriptive statistics, the input is always sample. It's not population. And the outcome also talks about the sample in descriptive statistics. So let's see what are the types of descriptive statistics that we have at hand. So descriptive statistics is majorly, one second. Is majorly having three branches. One is central tendency. The second one is dispersion. And the third one is shape of the data. So these are the three major branches that we are going to look at. So the first one is Central tendency. So what is the central tendency? So the data, whatever you take, is always having some center. So this is what is central tendency. So the data that you take is always having a center. So let's say I have heights information, the one that I showed. One person is 150 centimeters, another person is 155, 160, 180, let's say. So what we are going to look at as a central tendency is the center value, the mean or median value, which is lying exactly at the center. So there is an importance for this central tendency, but I am not going to teach at this moment, but you are going to learn going forward why we should go for the central tendency. That is a bigger discussion, so I'm not going to teach it now, but definitely in future. So all we are talking about this is the center value of the data, but it is like this, even if I don't say about the real application of it, but it is a very generic topic. So for example, let's say I get lot of Domino pizza orders. Okay, I get, let's say every day I'm getting 100 different orders from different 100 different customers. So let's say the first order is for $10, second order is for $50, third order is for $30, fourth order is for let's say $35, fifth order is like $15. Now if likewise I have 100 different orders. Now if your manager asks you how many what is the average order from Domino's, okay, if your manager asks you what is the average, what is the average what is it, sales, what do? You compute and give only one particular item. What do? 10 plus 50 plus 30 plus 35 plus 15 by 5. This is what we generally do as an average. Sum of the items by number of items. But why did your manager ask you what is the average sales? Any idea? Why didn't he has all the data, right? He has all the 100 records. Why didn't he go and look at that? Instead asks you to compute something else. What is the reason for asking us this average value? Subbu, are you
Maybe,
there? Yeah.
yeah. Maybe average value where the more customers are opting generally,
Okay.
approximately.
It is more customers.
Yeah. Where
So
more customers are lying their cost.
yes, that is correct. But say that the reason actually, so still he can look at all the 100 records, right? Why didn't he look at? So basically, this is a way to summarize the data.
Yes.
Even if you have 100 records or 1000 records or 1 million records, it is a very time consuming process to look at each of the record and then understand what it means. But if you look at only one average, it can mean it can mean that it is representing the entire sample or entire data, right? We are
Yes.
actually we're actually seeing the entire data in one value. So to summarize the data, we can see that. But the second reason and the most important is what you said. It's because many people lie around this average. Many of the purchases will lie around this average. It's not exactly this average. Let's say this is $35. Let's say I didn't calculate, but I'm just saying. So let's say this is $35, the average. Many people who purchased the Domino's pizza will be purchasing around $35, and very less people will be away from this average. That is the reason why we take average, and this you'll get in future. The exact reason, I mean, whatever I said is the exact reason, but once you go into the inferential statistics, you will keep learning this concept again and again. Okay, and this is what is meant by central tendency. There are, what it means is, when you take an average, most of the purchases are around this average. This is the reason why we take average every time. Is that clear, Vidya, Abid, everyone?
Yes, Sandeep.
Yes, Sandeep.
My one question is that, so
Yes.
there are 100 Domino's orders.
Hmm.
How did you pick these 5 data points or these data values? Just randomly?
No. I'm just writing 5 of the 100
Okay,
because
so
I cannot write all the 100.
okay.
Okay. My sample is only 100, but I was just explaining it through 5 points. Is that clear?
Yeah.
Okay. Now, in central tendency, there are many ways to do central tendency, and the first one is always average, which everyone I hope will know or understand. So how to calculate the average? And the average in descriptive statistics is denoted by x bar, right? Just now I said. So x bar equal to sum of the values by number of values. And let me show you. Let's say there are 5 data points: x1, x2, x4, and x5. Now, the sum of the values by number of values, how I can do is like this, right? x1 plus x2 plus x3 plus x4 plus x5 by 5. Now, if you have 100 data points, you have to keep on adding this x1 plus x2 plus x3 until x100. You have to keep on writing that. And in mathematics, always there will be shortcuts for these kind of things. And in this case, the shortcut is called sigma. Instead of writing all these x's, all you can write is sigma xi, because all it is changing is the number, the subscript number of the x, whether it is 1 or 2 or 3 or whatever. All the thing, everything that is changing is only the subscript. So in mathematics, what I can write is all this kind of summations I can keep a sigma notation, which means it is a summation of I, where I is running from 1 to 5. So what it means is I'm actually converting these number of terms into single term by n, which is 5. Okay, this is how I can do. And in most of the cases, wherever I write sigma notation, I generally try to avoid writing I generally write it as sigma x by 5. instead of writing this subscripts where it is ranging from. Is this clear? How to write the sigma notation?
Yes, Sandeep.
Okay. So that's how you can write averages in terms of sigma. Anyway, we can have an example of same dominoes example. Let's say now there are only 5 data points and the sales are $35, $25, or let me remove that dollar. It's all in dollars, you can assume 25, 35, 15, 10, and let's say 40. Now what is the average for this? X bar equal to 25 plus 35 plus 15 plus 10 plus 40 by 5, and it's going to be
25.
how much? 25.
It's 25 something.
It is 25. So okay, 25. Okay, this is how you can calculate averages. Of course, most of you might know, but in case you don't know. Is that clear? And the second one is median. Median is also closely related to averages. The only thing is it doesn't get impacted by the extreme values. Let me write that. Median doesn't get impacted by, instead of writing extreme values, I can also write outliers, right? Both are same now. I already explained this. Median is not, median will not get impacted by the outliers. Okay. And what is exactly median? It is the middle value of data, middle value in data after sorting. You have to sort the data or order the data. You can say ordering. You have to order the data in ascending order. Only then you can get the middle value. And it is also nothing but second quartile, right? Second quartile is equal to 50th percentile is also same as median. We already saw this. Is equal to median. All are same. Is that clear till now? So
Yes.
here again we can take the same Domino's pizza example. 25, 35, 10. What are the others? 25, 35, 15, 10. Okay, I can say 10, 15, 40. What is the median here? Anyone can try.
You have to sort the data 10, 15, 25, 35, 40. 35 is median.
10, 15 after sorting.
25,
25, 35,
40. Okay, 25 is median.
10, 15, 25, 35, 40, right?
Yes, only.
Now what is the median?
25.
25. Okay. So this is how you can do the median. Always the middle value. But what if the number of values are lesser? Let's say, I mean, number of values is not even, not odd. Sorry. So in this case, what you did, you took the middle value by taking out 2 from the left side and 2 from the right side. The middle value is the, sorry, this one. You took the middle value. But what if there are two middle values? When will it happen? When there is only odd number of data points. So sorry, even number of data points. When there is an even number of data points, you'll have two middle values, right? What is the sorting order? 10, 15,
25, 35.
25, 35. So there are two middle values. So median is only one value, right? So what you can do is you can take an average of the middle values. 15 plus 25 by 2. It will come around 20. Okay. When there are more than one, when there is more than one middle value, take an average of those whatever is the middle values, and that value will be your median. Is that clear till now?
Yes, Sandeep.
Yes.
Okay. And the final one is the mode. And what is a mode? Mode is nothing but the frequently occurring item. Whichever is the frequently occurring item, that is the mode. And mode is generally used for categorical data. Generally used for the categorical data. Okay. For example, you took a survey of different people and asked them what is your favorite color, and you want to find out what is the most frequent or mostly favorite color for many of the people. Okay, what is the common or most frequent color that people say that they are that they like actually? So the first person, let's say he said red. Second person, let's say green. Okay, and the third person, let's say again he said red, and red again, and maybe green. For simplicity, I'm taking only two different colors, but you can have n number of colors. Now, let's say my question is, what is the most common color that people generally like?
Red.
It is red. How did you know that?
It's most occurring.
It is the most occurring. Red is occurring for 3 times and green is occurring 2 times. You say red. That is nothing but mode. So here mode is nothing but red, because that is the most frequent item that is that people generally like. So this is about the central tendency, about mean, median, mode, and the central tendency.
Yeah, I got
So
one question.
yes.
So here, in case of calculating mode, you told that frequently occurring item is the mode. Let's say if I retrieve data from somewhere else and I got categorical data as most occurring items as like two items. Let's say for example, red is
Okay.
highest occurring.
Okay. Yeah,
green
I can.
highest occurring color. So how can I calculate mode?
I got you. Let me take another example. Let's say the example is here: red, red, green, red, green, green. So in this case, what is mode? Is that your question?
Yeah, it's Sandeep, exactly.
Okay. In this case, the mode is red and green. And this data set is called bimodal data. What it means is it has two modes, just that. But what about the other cases? Let's say what happens if the data is having red, green, and yellow. What happens now?
Red, green, yellow is mode.
No, actually there is no mode. There is only up to bimodal data.
Okay.
Okay. There is no mode here. Everything is different, right?
Yes, Sandeep.
So there always exists average, always median exists, but mode can exist or may not exist. It may not exist also for mode. Okay. For example, names. Let's say I take a list of names. In this class, you have Sandeep, Subbu, Abid, Vijay. What is the mode here? There is no mode. There is no repetition of any name, right?
Yes.
So in that case, there is no mode. Mode can be always, I mean, it's not always possible that you will always have a mode. It's always perfectly okay not to have a mode many times. Okay. So we are done with the central tendency. Any other questions on central tendency? It's a very easy concept. It's not very.
What is importance and application of these central tendencies, Sandeep?
We'll see. We'll see that.
Okay.
See, in entire statistics, without these mean median mode, will not proceed anything further without understanding this. So the application is the entire statistics. That's what I can say.
Okay.
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 At this point, you'll not know. You'll get to know. So
Okay.
Vijay, are you clear?
Yes.
And Subbu?
Yes, Sandeep.
Okay. Abid, you're also clear, right?
Yes, Sandeep.
Okay, we'll take a break now. I think this is a logical end of one topic. We'll take a break until 7:25. 7:25 on my clock because I cannot see your clocks. Is it clear?
Yeah.
Okay. We'll come back at 7:25 then.
Okay, Sandeep.
Is everyone back?
Yeah, I'm back, Sandeep.
Yeah, I'm also back.
Okay. Subbu, are you back? Okay, that's fine. Let's start then. So we are done with the central tendency, but we are not still done with descriptive statistics yet, right? So let's talk about so what are done. So descriptive statistics, central tendency is done. Now we have dispersion. Dispersion is something that is more important than central tendency because it gives more insight to the data than just having a central tendency. I'll show you in future. Now dispersion. Sorry, I'm always writing a wrong spelling. Dispersion. Now what is dispersion? Dispersion is nothing but it talks about sorry, it talks about how much the data is deviated from the center. When I say center, it only means that it is a central tendency. Okay, so we are talking about how much the data is deviated from the center in terms of dispersion. So there are three different dispersion metrics commonly used. There are many, but three commonly used. The first one is called range. I think everyone might have used range one or the other time. But range, so range is nothing but
Maximum minus minimum.
maximum minus minimum. So it's one of the simplest statistic that you can compute. Just get a maximum, get a minimum, subtract minimum from maximum. Okay. Again, the same example we can take. Let's say 25, 35, 10, 15, 40. 25, 35, 10, 15, 40. So what is the minimum of all these values? 10. And maximum is
40.
40. So range equal to 40 minus 10. It is nothing but 30. So 30 is the range. So what it gives you is so your central tendency is only talking about the middle value, right? Either it is an average or median or mode. It just talks about the middle value. It's not talking about how much it is deviated from the center. Okay.
Yes, Sandeep.
So with both median and standard deviation or mean and standard deviation, forget about mode for now. Mode is not useful in this kind of cases. In both median and average and median, you're only talking about the middle value. You're not talking about what is the distribution of the data. that distribution is only given by the dispersion. And we'll get to know about the real application once we go into the inferential statistics. But right now, both central tendency and dispersion together talks about your distribution of the data, how the data is distributed across the, how the data is distributed. Okay. So both central tendency and dispersion together are always used generally. And the second statistic that we can have, by the way, any questions on range? Range should be very easy. That's why. Okay. So the second thing is IQR, which is, we already talked about it, right? Yesterday. So it is interquartile range. And it is, the formula for this is, we already know this, Q3 minus Q1. Okay. We already solved a problem on this. We go back. Height data set. So we have a list of heights and we wanted to get IQR for this. How do we get this? First you compute Q1 and Q3, then compute Q3 minus Q1. This is the interquartile range, IQR. How do we do that? You type in equals and then type quartile. Select all the data, all the heights that you have at hand, comma, first quartile. Again, quartile. To select all the data, just select the first cell, Control Shift and down arrow. Sorry, Control Shift and down arrow, comma, third quartile. So we got first quartile value and first quartile value and third quartile value. What we have to do is subtract Q1 from Q3, which is Q3 minus Q1. So this is how you calculate the interquartile range. Is that clear? I think you already saw this example. Any questions till now?
No, Sandeep.
Okay. And the final one and the most important out of all, and you may have heard already about this, standard deviation. Okay, and this is most important out of all. And the standard deviation for sample is represented by S, and it is given by this formula. It is nothing but sigma x minus x bar whole square by degrees of freedom under root. Okay, we'll break this formula into pieces and we'll try to analyze each of them to understand how what is this formula doing. Okay, but here there is something called df, and we have no idea or no clue what is df. Anyone has any idea except Abid? I believe Abid should know already. Subbu or Vijaya, do you know what is the degrees of freedom?
I vaguely remember. I don't recall that much.
Okay. Subbu, I think you should know. You're a man of mathematics. Okay.
No, sir.
Okay. So that's okay. We'll learn about it. DF is nothing but degrees of freedom. and it gives how many variables are free to change. Degrees of freedom is nothing but how many variables are free to change. I'll explain in a simple terms. Let's take some example. Degrees of freedom. Remember that unless we learn degrees of freedom, we cannot do anything like this, right? You have to divide by something which is degrees of freedom, and I don't know what it is. That's why I started with degrees of freedom. Unless we complete the degrees of freedom, we cannot complete the standard deviation. So degrees of freedom. So I already mentioned how many variables are free to change is the degrees of freedom. But how to know that how many variables are free? Now let me give in cases. Case 1. The first case I can write is x plus y equal to 10. Now Vidya, can you open up your mic?
Yes.
Vidya, so in this equation x plus y equal to 10, can you choose any number for x? Choose any number, whatever you like.
Okay, I'll say 2.
2, right? Okay. So you chose x equal to 2. Can you choose y now?
I can't choose. I just have to make it equal to 10.
Exactly.
I don't.
You have to, since you have to, this is your formula that you have to accept and then follow. For this formula, if you choose 2, you cannot choose y, right? You have to fix y. If x is chosen, y is fixed. Let's take another case where if you choose y, let's say again any other number you can choose.
Say y is 5.
Y is 5. Again, can you choose x?
No.
So if you choose one of the variable and if you have to follow this condition, this is your condition, you have to follow this condition. If you choose one of the variable, the second variable is fixed. Now I can define degrees of free. I already defined the degrees of freedom as how many variables are free to change. Now in this case, if you have to follow this condition that x plus y equal to 10, then how many degrees of freedom you have? df equal
Only
to
one.
1. Only 1 degree of freedom is free to change. You don't have another degree of freedom to change. Okay. So how many variables you can freely change is your degrees of freedom, nothing else. It's very easy actually. Let's take another case, case 2. Now Subbu.
Yes, Sandeep.
Okay, in this case, can you choose x?
6.
6. Can you again choose some other, maybe z?
8.
8. Now can you choose y?
No, it is fixed in the
It is
now.
fixed. It is fixed
Yeah.
again. Now again, what is the degrees of freedom?
2.
2.
Yes.
Now to Abid, I'll give you a. Abid, can you open your mic? I'll give you a little bit tougher problem. Just because you know something. Okay.
Yes.
Now can you choose y? These are the conditions that you have to follow.
Yes. Amit. Uh,
Can you choose y?
yeah. Y equal to 10.
Can you choose z?
Z equal to 10.
Okay. Can you
X is
choose?
fixed. 0.
But actually, can you choose Z? If you have to follow this,
Yeah,
these two
certainly.
conditions, are you following your conditions? Y plus Z equal to 10. Are you following based on these two chosen values, whatever you chose?
Mm,
So can you choose Z again? You're not
yes,
following this condition.
Yeah, Sandeep.
Hmm.
Y equal to 10, Z equal to, I can choose Z as 0.
Are you choosing? Or is
Yes.
it fixed?
In the context of second equation, it's fixed.
In both the context. I don't care which context you are talking about.
Okay.
My conditions are this.
Yes.
Based on that, are you choosing Z or not? That you tell me.
Yes, Sandeep. Based on both equations, I'm choosing Z equal to 0.
You're not choosing, right? It is fixed. Can you choose one? Can you choose any other value for Z other than Z equal to 0?
No, Sandeep.
If you're not able to choose anything, but you're forced to use only that, you're not choosing, right? You're not
Yes.
free to change. You're not free to change it. Free to
Sandeep.
change.
Okay.
It's not free to change, right? So
Yeah, got it.
you cannot choose Z. You cannot choose X. Now, what is the degrees of freedom? How many variables you can freely change?
2.
How many?
Only one.
Only
Sandeep.
one.
Yeah, Sandeep.
Once you choose Y, you cannot choose Z. You cannot choose X also, because X is always fixed. The reason is Y plus Z equal to 10, which means you can X plus Y plus Z equal to 20. In place of Y plus Z, you can substitute 10, right?
Yes, Sandeep.
Based on the second condition.
Yes.
Which means X is fixed as 10. You cannot change X. And out of Y and Z, if you choose Y, you have to fix Z. Or if you choose Z, you have to fix Y. For example, the other case could be Z, let's say it is 5. Y is fixed as 5, right?
Yes.
X is already fixed. X is anyway fixed as 10. You don't have a way to change X.
Yes, Sandeep.
So how many variables are free to change in this case? In this context?
Only one.
Only one variable. Now, can I define degrees of freedom as n minus c, where n equal to number of variables and c is not number of constraints. Constraints, when I say constraints, it is nothing but the number of equations. Can I say that? Let's go back and check. It says generic formula I'm trying to put forward. Is it working or not? We'll see. Let me draw a box here. Okay, is it not drawing? Why is it not drawing? I don't know. Why is it not drawing? Just give me a minute.
Yeah, draw it with pencil, Sandeep. It's better.
Okay, that's fine. I'll draw it later. Now let me go back. Sorry. So the degrees of freedom, I said that it is n minus c, right? What is n here? N is the number of variables and c is the number of constraints or equations. So here n is 2, right? 2 variables, x and y.
Yes.
And c is 1. Only one constraint, which is x plus y equal to 10. So what is the degrees of freedom?
2
2
minus 1.
minus 1, which is 1. The same as here, right?
Yes.
And let's go to here. How many how many variables I have?
3.
N equal to 3. C is how much?
1.
Only one constant. Only this one is my constant. Okay. Degrees of freedom again is n minus c.
2.
3 minus 1, which is nothing but 2. The same as here, right? That's what we got.
Yes, Sandeep.
So we don't have to substitute values and try out and do all these things. All you can do is you can directly use this formula. Instead of substituting values and seeing how many variables are free to change, I can just use this formula. Okay, and final one. How many variables? N equal to?
3 variables.
And C?
2 equations.
2 equations. What is degrees of freedom again?
1.
3 minus 2, which is 1. Same as here. So what you can do is you can just use this simple formula instead of using instead of trying to substitute values and seeing how many variables are free to change. Okay.
Yes, Sandeep.
How will you know how many variables are constraints without doing the work?
Can you come back again? Can you give me?
Yeah. So basically, in the above examples, we went one by one, choose X or choose Y, and then that's how we figured out that, okay, in this example, X and Z are fixed. But we only know that because we went through this example that 2 are constraints. Just if somebody gives you the equation, how would we know how many are the constraints without working the problem out?
See, you need to know how many variables and how many constants. Only then this formula works, right?
Yeah, I mean, we can tell how many variables are there, but how do we know how many constraints are there without working the problem out? Like, would they tell
Okay,
us?
that you'll get to know.
Okay.
I'll show it in standard deviation. So
Okay.
we'll keep on using this formula and we'll try to derive these constraints as well.
Okay.
Okay. Once we start using this degrees of freedom in standard deviation, you'll get to know. That's not a problem. Okay. In general, you'll not know how many constraints are there. All you can know is, you will get to know, but the constraints, the number of constraints that you have is based on your problem at hand, and that constraints is always derived by the statisticians. It's not you and me. Based on the problem at hand, you will always know the constraints, and I'll show that example in the standard deviation. Okay, that that kind of problem we can solve in standard deviation. Then we'll come back to know how. We'll come back to your question. Is that clear? So I would suggest this kind of questions sometimes, sometimes will get covered in the future classes. So what I suggest is write down these questions somewhere in your notes, so that whenever we get to that point, you can see that question and you can see how it is already getting answered.
Okay.
Okay. So, but anyway, based on whatever that you have a constraint and you have variables. Based on those two things, are you comfortable now calculating this degrees of freedom or not? This is more important than finding out the constraints itself.
Yeah, with the formula, it's easy.
Okay. So once you get the understanding about the degrees of freedom, then we are free to understand standard deviation more. Okay. Now let me go back to my original definition about dispersion. What is my definition? It talks about how much the data is deviated from the center. What is the center? Center is nothing but the central tendency, right? Now, what is the central tendency that we are using here? X bar. We're already using one central tendency in the dispersion, which is X bar, average, right? So what we are doing is we are taking each observation in the sample and trying to find out the deviation from the center. And we are actually squaring it off and then doing a square root. We are doing some extra mathematics here. But actually, what we meant is here in the standard deviation, the numerator of the standard deviation, all we are doing is x1 minus x bar square plus x2 minus x bar square plus x3 minus x bar square. This is how we are actually calculating the standard deviation, right? So each term is actually a deviation from the center. The first term is actually how much x1 is deviated from the center, how much x2 is deviated from the center, how much x3 is deviated from the center, and we are adding up all the deviations and then saying this is the standard deviation. That's what we are doing actually here, right? Any questions on this, whatever I am saying?
No, I'm good, Sandeep.
Okay, so
Sandeep,
what
I have wondered why we are dividing with the degrees of freedom.
I'll tell you that. Okay,
Yeah.
do not worry about the why we are dividing by degrees of freedom, because maybe that part I will not tell. Why exactly on degrees of freedom I will not tell. The reason is there is something called biased estimator and unbiased estimator, and that is a little bit difficult to understand for you. So I'll skip that part, why exactly on degrees of freedom, but which degrees of freedom to use I will tell.
Okay, sure, Sandeep.
Okay.
Yeah, sure, thanks.
So okay, now what I'm doing here, I'm just talking about the numerator right now. I'll talk about again denominator later. So in the numerator, I'm actually doing is the exact definition what I gave for the dispersion. How much the data is deviated from the center. So every data point I'm taking, I am trying to find out how much it is deviated from X bar, which is my center. X2, I am actually again doing the how much it is deviated from the center. All of this, every point I'm taking this deviation. Now, what I'm doing here is I'm also doing a square. Now, why am I doing the square? This is more important to understand why I am doing a square instead of doing, probably I can also do like this, right? Why am I doing a square and then doing a square root? And this will give you the constraint that I'm talking about. And that's the reason why I'm doing all this. Are you clear so far? Or am I confusing you? Vijay, are you clear?
Yeah, I'm clear.
Okay. So till now I'm doing a deviation from the center, but I'm doing a squared deviation actually. Why should not I do a simple deviation? X1 minus X bar, X2 minus X bar, X3 minus X bar. Instead of that, why am I doing X1 minus X bar square, X2 minus X bar square? Why am I doing like this? So to answer this question, I need to understand what happens if I do this. Let's do a simulation and understand this. Okay. Now let me take only 30 points. I'm not taking the entire thing because it will be difficult to calculate these many points. It's just for my calculation simplicity. Okay. I'm copying this into another sheet. I'm taking the first 30 and thinking that this is my sample. Now for these things, let me do averages. Okay, let me add. Okay, sample. I'm writing this as a sample. My first 30 values I'm thinking as a sample. Now let me take average. What is average? Average of all these things. So this is my average, right? So all I'm supposed to do is every data point I have to subtract from the average. That's what it means by x1 minus x bar, x2 minus x bar, all these things, right?
Yes, Sandeep.
So what I'm doing is, this is x1 minus x bar. Similarly, I have to do for each of the data point, right?
Yes.
S1 minus x bar. Similarly, the third data point minus x bar. So since it is very difficult for me to do all the 30, in Excel there is a small shortcut to do this. The shortcut is, because always I have to use this same x bar, I have to use this as a constant. What I can do is I can keep a dollar here, $C, $2. Instead of saying the C2, C2 is this cell, C2. I have to use dollar here. What it will do is, it will make this this value as a constant across, and then I can just drag it on until the end. Now what happened is, every point it has subtracted with the same average. If you see, A2 is this one minus this average, A3 is this cell minus average. Likewise it did for everything. So what I did now, I did x1 minus x bar, x2 minus x bar, x3 minus x bar, so on until x30 minus x bar. All of these points I have done a deviation from the average. Now if I do, so there is another thing, right? It's not just x1 minus x bar, x2 minus x bar like this. I have to add up all of this. All of these terms I have to add. So what I can do, sum of, I take all of these and then add. What am I getting? I am getting a 0, and this is the basis for the entire statistics. What I am doing here is sigma x minus x bar, right? What I am
Yes.
doing till now, I took x1 subtracted from x bar, I took x2 subtracted from x bar, so on. I took xn minus x bar, and I did a sum of all these things. What I did, sigma x minus x bar is what I did. Sigma xi, where I ranges from 1 to n, sigma xi minus x bar is what I did. I can simply write it as, instead of writing that I notation, I'm writing it as sigma x minus x bar. And what is happening is, surprisingly, it is becoming 0. In fact, I can take another 30 maybe. Maybe I can take another 30. These are another 30. I'm randomly taking. I don't know what does it mean by these 30. If I take those 30 also, I'm getting 0. Actually, it is 10 power minus 13, which is very, very close to 0. Right? 2.84 minus 2.84 into 10 power minus 13, which is
Yes.
0 actually. 10 power minus 13 is 0, very close to 0.
Yes.
So, regardless of what I take as a sample, my sigma x minus x bar will always be 0. And because of that, the constraint that I have to satisfy in standard deviation is sigma x minus x bar equal to 0. Is that clear? Vidya, you asked me which constraint to use, right? This is the constraint in standard deviation you have to use.
Okay.
Anyone, any questions on this?
Fine, Sandeep.
So this is always going to be 0. This sigma x minus x bar is always going to be 0, regardless of which sample. I can take 100 samples and every one of the sample is going to be 0. It's a proven thing. I'm not proving that. I'm proving only by simulation, but it's a proven mathematics actually. Okay. Any questions, Vidya? Are you clear or are you confused?
No, I'm clear.
You're clear, right, Subbu? This part is very important. That's why I'm asking everyone.
Clear, Sandeep. Fine.
And Abid, are you clear?
Yeah, I'm clear till now. So here, while calculating standard deviation, you took square, right? So I just
Yes. I am taking square because sigma x minus x bar is 0, but sigma x minus x bar square is not 0. Let's say I take a square of each of them. This is x minus x bar, right?
yes, Sandeep.
Let me write it here. X minus x bar. Okay. Are you able to see this Excel sheet properly? I mean,
Yeah, yes, Sandeep.
or is it the font is very low?
No, it's viewable. It's okay.
You're able to view, right? Or I can, maybe this time it is better.
Yeah, this one is better. Yes, Sandeep.
Please let me know if you cannot see anything. I'll do the necessary things. Okay, this is x minus x bar. Let's say I do x minus x bar square, which is nothing but this one into this one, right?
Yes.
Same one. F2 into F2 square. If I do square of all of these and then do sum, which is sum is nothing but the sigma part. Sum of all this. This will never be 0. Sigma x minus x bar is always 0. And sigma x minus x bar square is not 0. Not always 0. Never 0. Unless for some specific things. Okay.
Okay.
Are you clear now?
Yeah, yes, Sandeep. Now I'm clear.
So your standard deviation, if I say it is always 0, is it useful? It's not useful.
Yes.
That's why we are taking a square, adding up all the terms, then taking a square root to offset the square.
Okay.
Okay.
Yeah, yes, Sandeep.
I hope everyone is clear now. Why square and why not doing a deviation directly?
Yes, got Sandeep.
Okay. We'll complete. We are not yet complete on standard deviation because I have not described degrees of freedom in the context of standard deviation. So that we'll do tomorrow and complete standard deviation and continue from there. Okay. Vijay, are you clear? Vijay, Subbu.
Yeah, it makes sense. I just wish there was a formula easier than in Excel to compute standard deviation.
Yeah, there is. Don't worry about that.
Okay.
Because unless see all these things, if you see, even the quartiles, percentiles, there is a simple formula, right? Ultimately, the quartile formula is just a quartile and the array, and right.
Yeah.
So similarly, you'll have a standard deviation formula, standard deviation sample. Okay.
Yeah.
You have a very simple formula, but the thing is, unless you know these intricacies, why are we doing sigma x minus x bar whole square. Why not I remove the square? What should I use as a denominator? Unless you know these, you cannot understand some higher concepts like ANOVA, regression.
Yeah.
Okay, all those concepts you will not be able to understand. For standard deviation, it is definitely fine, even if you don't understand. But if you are going beyond standard deviation, you need to know all these things. Okay.
Yeah.
Hopefully, I did not confuse you on standard deviation, on degrees of freedom, because it looks very simple formula, the degrees of freedom, which is n minus c, but it's going to eat your brain. I know that. Okay. Any more questions before I close?
No, not from my end.
Okay. Okay then.
All right, Sandeep, we'll meet tomorrow.
Okay then. Yeah. I'm just waiting for any questions. Okay then. If you don't have
Yeah.
any questions, we can catch up tomorrow.
Sure, Sandeep. Bye.
Okay. Bye.
Bye.